My name is Alexander, and I'd like to present a project where we migrated from Subversion to Git. Actually, that migration is still ongoing. Before I start, first I would like to give a big thank you to Gerrit for organizing, hosting, and sponsoring this event, especially to Luca, sleeping so few hours. One warning, this presentation has not been made with PowerPoint. So this is the first presentation for a long time that I prepared without PowerPoint. I hope it will work better than PowerPoint. Let's see. What I'm presenting today is a case study where we migrated a rather old Subversion repository from Subversion to Git. There was about 17 years of history. And in doing so, we wanted to switch from a Subversion poly-repo setup to a Git mono-repo setup so that we can avoid the hassle with dealing with many different Subversion repositories. And to ease the transition from Subversion to Git, the idea was that we have a solution for a bidirectional hot sync between Subversion and Git so that developers and automation systems could work with either system. Also, commits would be possible to either system, and they would be synchronized with a short delay between each other. And that synchronization uses a slightly customized version of Gerrit. So let's start. I guess most of you won't know me. I guess nobody knows me. I'm not an active contributor to Gerrit. I'm just a user. I grew up in the 80s in the golden age of 8-bit computing. Then I went to university, took degrees in computer science, and since about 20 years I'm working as a freelance consultant, mainly for CI/CD. I originally come from the automation, test automation area. Then I got into CI, and when you work with CI, then you get your hands on all kinds of connected areas, including SCM, which is one of my focus area recently. I like to work with embedded systems because it's all small and self-contained, and you have everything under your control. And even if the embedded system is a 4G or 5G base station, it's immensely complex, but it's still a nice thing to work with because you have all the source at your hand, and it's fully under your control. I've been using Gerrit in various projects in various companies. I used it at Infineon, this semiconductor company. And the biggest Gerrit installation I've seen so far, I've seen at Nokia. And it's a funny coincidence that the next presentation will be given by Jose, who will give details exactly about that project. And that will be a very interesting presentation. And for me, it will be interesting to see what happened since 2019 when I left the project. Right now, I'm working for a smaller company, which is called Utimaco. Utimaco is a German company, which has about 500 employees globally. And it's active in the IT security business. One of their business units is the development of so-called hardware security modules. Utimaco was kind enough to grant permission to present this case study here at this user summit. So a big thank you to Utimaco. Regarding the actual product, that will be interesting, maybe what source code we are talking about. A hardware security module is an embedded device for securely performing cryptographic operations, like authentication, assigning activities, or encryption. And you can find them in many places. So if you switch on your mobile phone in the morning, some HSM will be involved in the HLR of the mobile network to authenticate your SIM module against the mobile network. If you do any credit card payment, HSMs will be involved. And also when you are at least traveling the German motorways with a truck, the toll collection systems which are built across the roads, they will have HSMs built in to organize the payment process. Since HSMs are used in so many security-sensitive areas, it's often the case that they require certification by some official body. I guess some of you will know about the FIPS certification. There's also an ISO certification scheme called Common Criteria. And these certifications both cover the hardware aspects of the unit, like tamper resistance. They involve an audit of the software, but often they also involve a certification of the entire development process, including the version control system. And that makes it sometimes difficult for companies that are active in the security sector to easily switch from Subversion to something more modern. Because if Subversion was certified for the development of a product, you cannot easily switch from Subversion to Git, because that would require a costly and lengthy recertification. This is how the HSMs look like. It's a PCI Express card. You cannot see much more than the battery here and the cooling device, but you will find a CPU there and some cryptographic accelerators below the cooling. The whole thing is also sold as an appliance, which is a 19-inch Linux PC with a custom Linux distribution, and the PC just holds the PCI card that you've seen on the previous slide. And the source code, both for the PCI card and the whole Linux system that you see here, is maintained in the Subversion repository we are talking about. Yeah, maybe I hope that many of you will no longer have to work with Subversion. So it's a valid question, why would anyone want to work with Subversion in 2022? One point is the certification requirements that I just mentioned. Another point is that switching version control systems is always a very disruptive step, because it affects so many systems. It affects everything from people to processes to automation systems. And yeah, you try to avoid such a disruptive step. And especially when you're a smaller company and you have customers in your neck asking for new features, it's very tempting to postpone the migration just for another half a year in order to generate revenue from implementing this new feature.
Yeah, it's a very valid point. I see still many customers working with SVN, even in 2022. One reason is binaries. They are putting binaries in the repositories and do it a lot. Now, coming to Git, the first rule is remove your binaries. But it's simpler to say as to do. You have to entirely change your workflow, deployment, publishing, introduce some other repository where you store the binaries. You don't have this issue in this case?
We do. We have lots of binaries as well.
Okay, so how you solve this?
We took the simple approach. We used Git LFS. Okay. So as part of the migration, we put all the binaries to Git LFS. That worked quite well. The problem is that we did this initial switch 2 years ago when we didn't know all the LFS file types which should end up in an LFS. So by now the bare repository grew quite big, and we will repeat the migration once again. But that's really a good point. So the way the handling of binaries in Subversion is much more convenient than with Git, because you only see the latest version of the binaries in your local copy. Yeah.
So you use LFS plugin?
Yes.
Ah.
Yeah. 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 It's good to mention that because this switching of version control systems is such a disruptive step, what we try to do is to have a setup where we can run both systems in parallel, so that we can switch piece by piece from Subversion to Git. And that worked quite well. So a few information on the magnitude of the Subversion server we are talking about. There's about 200,000 commits. Spread in 300 distinct repositories, which are hosted by the same Subversion server. There's literally thousands of tags and branches. The on-disk size is about 30 gigabytes, mainly because of all those binaries which are there. Yeah, there's many blobs. The structure is not the nice and friendly standard Subversion layout where you have tags, branches, and a trunk, but you have all kinds of things which happened in the past 17 years, like somebody accidentally copying a trunk inside a trunk, or creating a tag inside a tag, and then deleting that again, and that's quite a mess. Yeah, the last point. There's hundreds of repositories, and the setup that you use in Subversion for integrating this stuff is typically using Subversion externals. So these are heavily used in this repository for gluing everything together. For building one of these standard HSM products, typically some 120 individual repositories are glued together via Subversion externals, which is quite a nightmare, especially for the release team. And we wanted to get rid of this as well by switching to a Git mono-repo setup. And yeah, you will see how we did this on the next slides. So the migration strategy was that we performed 3 steps. The first step is a base conversion, where we wanted to convert everything that ever existed in Subversion one-to-one to Git. So all the branches, all the tags, all the commits we wanted to have in Git, so that any future comparison between legacy tags or between old branches should be perfectly feasible in Git. Also blaming all the commits, blaming the source code should also work in Git. So that was one key requirement here, that we could really basically switch off the Subversion server, and also historical data will be fully available in Git. The second point is we wanted to switch to a mono-repo approach. So we had to find a solution for replacing the Subversion externals that were used on the Subversion side. And the last point is we wanted to have a hot sync between both systems, so people could work with Subversion, either with Subversion or with Git concurrently, both in read and write mode. And for that, we have a slightly modified version of Gerrit. So let's start with the first point, the base conversion. I try to keep this short since it's not really related to Gerrit. But the important thing that I would like to point out is that Git SVN is not a repository migration tool. It's a tool that is intended to migrate, to synchronize individual changes between Git and Subversion. And for that, it's a good tool. It's working fine. As you will see, we use it also for the synchronization in the third part of my presentation. But for migrating a huge number of commits in a huge repository from Subversion to Git, it's not the proper tool. It's quite difficult to find a good alternative for that, because if you do a Google research for repository migration from Subversion to Git, I think 95% of the solutions will recommend to use Git SVN or some tools which are built up on Git SVN. But there's a better tool, luckily. It's a bit hidden, but if you... maybe it's good to point out the issues with Git SVN. Maybe the most important issue is that it's so slow. I think for converting 200,000 commits from a big Subversion repository to Git, Git SVN would probably run around a week or so, which is okay for a one-time activity, but typically you have to fine-tune the migration process because you find some trunks inside trunks which require special treatment. Okay, so after 1 week of conversion, you find out that you need to fix that. You start the next iteration, you again wait for a week to find out that you need to fix something else, and that doesn't work in practice. So the feedback cycles are way too long with that. And there's lots of border cases which are difficult to handle with Git SVN. I won't detail on those here. So the better tool to use is a tool called Repositories. Repositories is a tool, it's written in Go. It's specifically designed for converting from many input repositories to Git. It has been used for converting the Subversion repositories for the GCC compiler suite from Subversion to Git. The Blender rendering tool has been converted using that. So there's some good references, and also the author of Repositories, it's Eric Raymond. He's some dinosaur in the open source community, and so many Unix tools have code from him included. So he's certainly somebody who knows what he's doing, and from what I saw from Repositories, that's confirming that. So it's really a mature tool which is still actively maintained for several years already. And yeah, a few key points are that Repositories is extremely fast. It has additional tools that allow you to fine-tune the conversion process using stripped-down versions of the original repository, which has all the objects replaced by string identifiers, which doesn't matter for the conversion process per se. And if you work with that, you can migrate the repository I'm talking about in less than 10 minutes. And that makes it very convenient to optimize the conversion process. And even the full-blown conversion using the full binary data will complete in about 2 hours. That's if you compare that to the runtime of Git SVN, that's amazing. Partly this is because repository will directly read Subversion dump files, so it will not interact with the Subversion command line. It will read the internal dump format of Subversion, converts it to internal data structures in repository. Those you can modify with certain commands, and the output is a git fast import stream that is used to create the Git variant of the repository. The tool handles all kinds of border cases. It's very powerful, but as with all or many powerful tools, there's a steep learning curve. So it's not self-explaining at all. But the task is not an easy one, so it's somehow fitting the task. And if you do such a conversion once every 10 or 17 years, then it's worth the effort to spend the effort for that. So after running repository on this Subversion repository, what's the output? On this slide and the following ones, I will focus on 3 example repositories which are hosted on the Subversion server. The first one being the red module A repository, which has a trunk. And in this trunk of module A, you will find a file AAA.c. And in Subversion, that's a flat path. In Git, that will be mapped to a Git branch called module A/trunk, which has the same file in the tree that belongs to the branch. For tags, it works very similarly. So a tag called rel 1.0 for the mod A repository will be mapped to a tag in Git called mod A release 1.0. If you have branches, like for this module B, which has a development branch or a dev branch with a file BBB.c for repository B, it will naturally map to a Git branch called mod B/dev. And even if you have nested repository names like the yellow one, prod/x, and there's a trunk with a makefile, then it will be mapped on Git side to a branch prod/x trunk. So that's very straightforward, and that gives us full access to whatever, to everything that ever existed on Subversion side. Except one thing we didn't handle, it's the Subversion externals. Not sure if everybody knows how Subversion externals are working here, so very brief summary. Subversion externals are basically a text property that can be assigned to directories in Subversion, and that text property will be evaluated when you perform a Subversion checkout. And when Subversion finds such a text property, the text can require to check out further directories in the subdirectory of the existing folder. As an example, let's say that the yellow repository here, this trunk for product X, is a product repository that just orchestrates the build of all the other modules which are pulled in. So the typical way to use externals would be to set the externals definition for this prod X trunk repository in Subversion, and to add some definition here that in the subdirectory src/a, you want to have the content of the trunk of the module A repository, and in the subfolder src/b, you would like to see the sources of the development branch of module B. So when you check out in Subversion the yellow branch, you will not only get the makefile that is really on the branch itself, but you will get also subdirectories here that contain full Subversion checkouts of the corresponding repository branches. That's how the externals work. Which brings us to the mono-repo, the second point. Because you can actually forget about the other top-level repositories that you've seen on the previous slide here. You will get them anyway if you check out the yellow repository. So as a developer or as a release manager, it's fully sufficient to have this prod X/trunk, and you will automatically get the red and the green parts. Now, how would you possibly get the same in Git? Excuse me? Yes, that's a very natural way to do that. But with submodules in Git, you have again the same problem that you have with Subversion, that you have to orchestrate, in our case, more than 100 submodules, which will be a similar nightmare to managing 100 Subversion externals to get something aligned to work. So we really wanted to get rid of submodules. But maybe we get closer to that if I ask the question that way. All the input branches we already have in Git. So in Git we have the yellow part that has been converted from the repo search and conversion. We have the red one, we have the green one. We just need to glue it together. Any other ideas? Yes, also? Yes. And the links will point to something that has been merged. So we use a merge operation for putting together the red and the green and the yellow part. The only thing that has to be solved is that we have to avoid clashes in the names that appear on the three branches in this case. So if all the three branches had a makefile on top level, we couldn't merge it together because we had a top level merge conflict. So the idea is to add a prefix to the paths before we do the merge. And then we'll add symbolic links to establish the same directory structure that we've seen on Subversion before. I will show you this in an example. So on the bottom side, you see the Git versions of the three input branches. And the first thing is we add a prefix there that corresponds to the name of the repository. So the AAA.c file will be renamed to module A/AAA.c. We add the same prefix for the green repository. The prefix is module B because it originates from the module B repository. And the prefix for the yellow repository will be prod.x. Then we can use these modified branches to create a mono-repo branch. Let's call it master X because it relates to the yellow product X trunk. And first we merge in the red part, then we merge in the green repository, and then the yellow one. Then we have everything put together. And the only thing that's still missing is the symbolic links that will replace the directories that you normally see in Subversion. So if you check out this master X branch in Git and you go to the subdirectory product X, what you see will be fully the same as what you get in Subversion when you check out the trunk here. The only difference is that in Subversion you will get really real files, real directories here, and in Git you will see symbolic links pointing back to the top of the repository where the other branches have been merged. So the whole build process will transparently work also in Git because the directory structure is completely the same. The only thing that is important is that your build system will work fine with symbolic links, which was a challenge at least on Windows-based systems, but also there we managed to get it running. Yeah, one thing I would like to note is that we did not modify the red branch here, as you can see it here, because the idea was really that the module A trunk branch is fully identical to what you get when you do a Subversion checkout on the trunk of module A. So having this mod A prefix on the red branch is not a good idea. And we added these prefixes as part of the merge process. So here in the first step, first we do the merge, but we don't commit it. And then we use the git retree command for adding the individual branches which are going into the merge, and we add the trees with the prefix here. Then we add the symbolic links, and then we commit the merge at the end. So that's effectively how you would do it if you do this by hand. Which brings me to the third part. Now we are in a situation that we have all the stuff that existed in Subversion, also in Git. We have also the aggregation of multiple branches, which was done in Subversion with externals. We have it done on Git side with the merge operation. Now we want to do a hot sync so that further changes which are done in Subversion will also appear in Git, and that modifications which are done in Git on this master X branch will be reflected in Subversion. That's what's meant here by hot sync. And for implementing that, we did a few assumptions. And one of them is that we only wanted to have a single truth. We really wanted to avoid a situation that we have two repositories with different content. So we really didn't want to have any ambiguity what's the proper place to find something, where to find the source code for a certain release. For that reason, we decided that we only want to have one single source of truth, which would be the Subversion repository. And it's a Subversion repository because all the existing processes and release processes and CI systems were still tied to Subversion. So that's the reason why Subversion was selected here. When we eventually switch off the hot sync, then Git will become the reference and the SVN state will be frozen. But for the time being, for this synchronized transition period, Subversion would be the single source of truth. The second point is that this hot synchronization between Subversion and Git was restricted to certain branches only, like, for example, this yellow branch that you've seen before. It sounds like a big restriction, but actually you can select any set of branches. You can use branches like the yellow one you've seen before, and in the real case in this repository, the yellow branch would have some 120 externals, which means that the mono-repo branch in Git would synchronize to 120 different Subversion repositories and branches. Or vice versa, this means that there's no hot sync for any other Subversion content. So if somebody adds a new module XYZ to Subversion, which is not used on any product, which is not consumed by any externals in the set of synchronized branches, it will not appear in Git. It can be synchronized explicitly. If we repeat the base migration that I explained in step 1, we can just rerun repository. It will create again all the tags and branches that exist in Subversion, and then we can push that over to Git once again, and then we will have the new stuff also in the Git repository. That's well possible, but it's not a hot sync, because as I said, it takes a few hours to do that. So we don't do that. Actually, we are doing that right now after 2 years. Nobody was really missing all the tags that existed only in Subversion. But in theory, it could be done every couple of hours. So let's get to the details of how the synchronization does really work. And I will split this in 2 parts. The first one will show how the migration how the synchronization happens when a change is done in Subversion and how this ends up in Git. The starting point is the post-commit hook in the Subversion repository. The post-commit hook is a script that the Subversion server can invoke after every new commit that has been done to the Subversion repository. After that, we will use the Git SVN command for getting all the changes from Subversion, but Git SVN, we are running in this case on the root folder of the Subversion server. So it's not tied to a specific repository or to a specific branch of a repository. It's really going to the root folder of the Subversion server, which has typically hundreds of thousands of files, because you will find all the branches and all the tags in one big tree. And we are fetching that into Git. And then we use this huge tree and modify it according to the synchronization set. For example, if some lines in this tree or some entries in the tree correspond to the mod XYZ, it will be removed because it's not part of the synchronization set. So that's the first thing that we have to do when we modify this big tree. Another point is that we have to fix the branch names which appear in the big Subversion tree, but which we removed when we added the prefixes for this and the merge operation that I mentioned before. And finally, we have to add the symbolic links for mimicking the directory structure that we had in Subversion. As a last point, we also have to account for Git LFS here, because after the initial repo search and run, we did the migration of the binaries to Git LFS, and we have to account for this in the synchronization process as well. So let's have a look at an example. This upper left box could represent the state of the Subversion repository when the base migration has been done. So this could be the state that has been used for creating the initial state of the master X branch, which has all the content of the synchronized branches. Now let's assume that somebody does a commit to this Subversion repository, adding or modifying the AAA.c file on the trunk of the module A. This will trigger the Subversion post-commit hook, which in turn will trigger the synchronization script, which in the first step does a Git SVN fetch on the root of the Subversion repository. that gives us a branch in Git. I call that branch Git SVN, which is a really huge branch, or it's a branch with a really huge tree, because this can have millions of entries. And one of these entries will have the new file, the new version of the AAA.c file. So that's the initial step for getting the data from Subversion to Git. Now, as a next step, we have to tune this huge tree down, or we have to modify this huge tree so that it fits the data that we want to see on the synchronized Git branch. So we use the git filter branch command here, and it will run a script that has as input the set of synchronized branches. And it will trim this huge tree down to the structure that we want to see in Git later on. So, for example, this trunk component in the path will disappear. So mod a/trunks/AAA.c will become mod a/AAA.c. And also these 3 dots will be gone. So this huge tree, which used to have millions of lines before, millions of files before, will reduce to a much smaller tree, which only has those files which appear on those branches which are subject to the synchronization set. Then we basically are done. The only thing that remains to be done is the git-lfs migration. So this remap branch has to undergo the git-lfs migrate import step, which in this case probably will lead to the identical branch that you've seen before, because this is a C file which we don't maintain in LFS. And then this change is what we need to bring to the destination branch. So we can now do a git rebase for rebasing this change on top of the master X branch, leading to a new version of the master X branch, which has exactly the change here that was done in the first place on Subversion side. That's the key idea for the migration from Subversion, for the synchronization between Subversion and Git. Now for the other direction, how do we synchronize from Git to Subversion? Here the starting point is Gerrit. So the workflow is the usual Gerrit workflow. You get the code, you upload your patch set to Gerrit, you get the code review +2, and then in the end somebody presses the submit button to trigger the merge. But in order to ensure that the reference data is in Subversion, at this point we will not directly merge the change to the destination branch, but instead we will push the change to Subversion directly. And then we wait for the Subversion to Git synchronization cycle to start, the one that you've seen before. And that ensures that in Git we will see exactly the same stuff that has been committed to Subversion before. So the timestamps, for example, will be completely identical to what you see in Subversion. Again, an example, and this time I will start from the bottom of the screen, because that's the Git side of the synchronization process. Let's again assume that somebody uploaded a Gerrit change modifying this AAA.c file on the mono-repo branch. And now somebody hits the submit button, and then the synchronization kicks in, which will exactly do the same steps as before, but in reverse order. And the first thing that we have to do is to re-import the binaries onto this branch, because the binaries are directly kept in Subversion. So we do a git lfs migrate export step for pulling the binaries back into Git. Probably in this case, as before, there won't be any difference between these two branches. And the next step then would be to, again, filter this branch for performing the same changes as before, the same modifications as before, but in reverse order. So for example, a git tree entry mod a/AAA.c will be translated into an entry mod a/trunk/AAA.c, because in the synchronization set we defined that we want to see the trunk of the module A in Git. And that will be evaluated reversely for modifying the paths here accordingly. Strictly speaking, the symbolic links should also be removed. I think we don't do that, and it doesn't really matter, because for putting the stuff back to Subversion, we are not using Git SVN, at least not directly. So the standard way of working with Git SVN would be to somehow put this onto the Git SVN branch and then run Git SVN decommit. That we wanted to avoid, because the Git SVN branch is so immensely large, which has millions of entry, and doing some rebase operations on that is extremely slow, and there's actually an easier way to do that. And the easier way is to use a command called git SVN commit diff. I think it's a somewhat internal command of git SVN, but it's documented and can be used. And what the command does is it computes difference between two trees, this tree and this Git tree, and the difference will be applied to Subversion directly. So if the last synchronized version in Subversion is that one, the git SVN commit diff command will apply the difference between these two trees, which is the modification in the AAA.c file, directly. That will be directly committed to Subversion to get a new Subversion commit. At that point, the Gerrit change has been merged to Subversion. What happens after that is that the post-commit hook of Subversion will kick in, and it will trigger the synchronization from Subversion to Git, which brings this change to the target branch, the master X branch, that was originally the target for the change that has been submitted to Gerrit. So that does mean that in the end, in our setup, Gerrit does not merge any changes at all, at least not to Git. So the changes magically appear on the destination branch in Git only because they first go to Subversion, and then the Subversion to Git synchronization kicks in again. We are using a nice side effect of Gerrit, since, well, by coincidence or by design, I'm not sure, but Gerrit will notice that something or somebody has merged the change to the target branch, which in this case was the Git SVN, was the Subversion to Git synchronization. So in that respect, we implemented sort of a new submit type, which could be called external merge. How does it look from the user point of view? That's the Gerrit that we are running, and as usual, the starting point is that somebody presses a submit button. It has to be confirmed, and then, that's different from the standard behavior, there's a small alert popping up indicating that the synchronization to Subversion has been triggered. Shortly after, in the console, you will get the Subversion revision information that is resulting from putting this change directly to Subversion. And a bit later, yeah, it's insane, but so it's matching Subversion. And a little bit later, the synchronization from Subversion to Git has been completed, and Gerrit will notice that somebody has pushed the change to the destination branch. And then also the status of the change, and Gerrit will switch to this green bullet in the upper left corner indicating that the change has been merged. The scripting for the scripts for performing the synchronization in either way is implemented in Jenkins so that we have a nice interface to the console output. But it could be done in any way. But we have these hyperlinks here, so if something goes wrong, we have directly access via web interface to the output. How long does this all take? It's surprisingly fast. So the more complex part is the synchronization from Subversion to Git, because you have to run Git SVN on this tremendously large tree. And actually the repositories where we are performing this Git SVN synchronization, they have a repository size of about 30 gigabytes or so. So it's, yeah, lots of data there, because you have the flat checkout of the root repository of Subversion, which still includes all the binaries, of course, so that's why it's so big. In the other direction, there's two components. First, we have to account for the time that it takes for running this git SVN commit diff command for applying the patch directly to Subversion. That's really fast. It takes 10 seconds when there's nothing to be converted for LFS. It takes a bit longer when we have to run git LFS. And these times already account for the overhead for triggering the Jenkins job. And yeah, so I think the effective time that is needed here is much less than 10 seconds. If you sum up the 10 seconds or the 60 seconds here with the 60 seconds for the synchronization in the other cycle, you will get the total turnaround time that it takes for a user to see that his Gerrit change has been merged to Subversion. So it sums up to 70 seconds or about 2 minutes when there's LFS specific content in the change. Yeah.
You started migration from Subversion to Git.
Yes.
Now you ended up maintaining 2 different repositories and making the synchronization all the way along between them.
Yeah.
But what is the scenario at the end of the day? I think it was get rid of SVN entirely. And
Yes.
What is still missing to get there and stop this insane workflow?
Come on, it's almost a standard Gerrit workflow. We have some teams which are not using Subversion the Subversion way. For example, we have people in the documentation team which are using Subversion on a shared copy on a network folder. And that's a working model that you cannot properly reflect with Git, because a shared working copy with Git is very hard to achieve. So those people first need to find a new process for cooperating.
Actually, as you notice documentation, I was contributing for LibreOffice project, and they have 2 gigabyte big repository, and they use Gerrit inline edit. I was contributed to inline edit to stop cloning the repository. So actually, to write documentation in Gerrit, it's even possible in browser. You don't even need to clone it.
I will suggest that, or maybe not. Thanks. Yeah. Yeah, another reason is that there's ongoing development, which maybe started in Subversion, and they didn't want to interrupt the ongoing development for a product before finishing it, but then you have overlapping releases and the next product starts already because the previous one, well, so you cannot find a good time for doing the switch, and that's why we have this parallel operation, so you have a smooth switch, so those people who can and would like to work with Git and Gerrit can do that right away, and all the legacy systems like release processes or product versions which are subject to certification can still be maintained via Subversion. That's the background. But I fully agree, we never intended that this setup runs for 2 years, because that's what happened.
But as you mentioned that the release process and that you don't even have a migration path to cut over, or you do?
We do. So know that we have special workflows like in the documentation team resolved. The only really blocking point is the handling of code that is subject to certification. And that will continue to be done in Subversion, but that will be done only in Subversion. So we hope to stop this synchronization setup that I presented today by the end of the year. And then the reference will be in Git only, and we can hopefully get rid of this.
Do you have dedicated Jenkins executors to do this, or does it share the same pool of executors with everything else?
That's a standard Jenkins. So the synchronization jobs are rather lightweight. So except for the disk space that you need for the synchronization repositories, this is quite efficient process. So there's not much computing power required for that.
Okay. I was mostly wondering if it's ever the case that it needs to wait for other workloads to finish because all the executors are busy with something else.
We have dedicated executors for that. So it's a dedicated machine. Yeah.
Cool. Thank you.
Yeah, thanks. Few more words on the scalability. So the synchronization time depends on the size of the flat of the root tree of the Subversion repository. And when we started 2 years ago, there was about 1.2 million files in the root of the Subversion server. Now, 2 years later, it's about twice the time, and the synchronization times have doubled. Mostly because of the Git filter branch, which is quite expensive to run on such a big branch or on such a big tree. I think that can be optimized, but hoping that we can get rid of the synchronization really soon now, we didn't go for that. And now we have turnaround times of about 5 minutes, which is not great, but it is what is somehow still acceptable. A few words on why we are using Gerrit for this synchronized operation. A nice feature of Gerrit is that you have the atomic nature for changes. So when a change is merged, you don't merge a whole branch with individual commits, but it's always one commit that will end up in Git, and the same will pop up in Subversion. So there's one-to-one relationship. There's no race conditions that you are merging 10 commits for one change and another 10 commits for another change, and maybe after 5 commits you find out that there's a conflict, and then you have 5 out of 10 commits submitted to Subversion, and the other 5 are somehow in an unknown state. That would be very difficult to handle. So there's no race conditions. We want to avoid merge commits, and this standard rebase strategy that you can use in Gerrit fits very nicely here. And the rebase strategy is actually the one that we hacked for implementing this external merge operation in our customized Gerrit. The external merge was quite easy to implement because Gerrit will auto-detect that somebody else has merged a change to the destination branch. That's a nice side effect. And last but not least, Gerrit's rather compact open source solution, so even for somebody who's not too proficient with Java programming like me, it was feasible to implement what we did here. Our Gerrit setup, I think I will skip that one. I thought that one would be still interesting for you. The experience from introducing Gerrit at a smaller company. So before I've seen Gerrit mainly in bigger companies like Infineon or Nokia. The problem in smaller companies is that everybody knows GitLab or GitHub. So Gerrit is really an underdog. So it's, I think, when you have a team that is dedicated to configuration management, you will have experts who do a detailed analysis of what is the best tool, and then there's a good chance that they will find Gerrit. But if you talk to a bunch of developers, or maybe somebody who's not so experienced with configuration management, his first guess will be, okay, we take GitLab because everybody is using GitLab. Is there anything else? So you have a hard time to argue for Gerrit in such a setup. And an enabler here in our case was the very simple installation of Gerrit. So as you mentioned this morning, it's a walk in the park. You download the BOR file, some configuration, and it's running. And it's running well. You don't have to care about any licensing stuff. You fire it up. And in our case, it's running smoothly for 2.5 years, and it's basically zero administration. It's not a huge setup that we are running, but still, it's personally, I was surprised that it's running so well. Yeah, this weird Gerrit workflow, or somehow weird Gerrit workflow, where you amend your changes before pushing, that was adopted by the developers more easily than I expected. So that's a good point. And now they like Gerrit and they are reluctant to let it go. We suffered that pain already. We started with Gerrit 3.3 and rebasing our changes on top of 3.4 took us a few days. Yeah. Yeah. So we did some modification to the Gerrit core, to the submit strategy for rebase, and we extended the hooks plugin for calling this external synchronization script. And I will skip the summary of the modifications. Yeah. So good point is that the whole setup is running fine for 2 years already. The bad point is that the setup is running reliably for 2 years already. But hopefully that will be ending the end of this year. We are still somehow blocked by having Subversion in the back. So we hope to get rid of that. And Gerrit runs really super stable. As mentioned before, it's a low maintenance solution. So kudos to the maintainers and contributors to Gerrit. Thank you.